Hi everybody, my name is Sadia Afroz. I'm a PhD candidate at Drexel University. Aylin and I are going to talk about Stylometry and Online Underground markets. This work is a joint work which is done in collaboration with Ariel Stollerman, our advisor, Rachel Greenstadt, and Damon McCoy from George Mason University. So this would be our third talk at CCC. We might give the first talk at 26C3, where he introduced this concept of adversarial stylometry, which shows that if you change your writing style, authorship recognition algorithms won't be able to recognize you as the author of a document. In last year's CCC, we presented two tools, JStylo and Anonymouth. JStylo is the authorship recognition tool, and Anonymouth is the authorship anonymization tool that uses JStylo to analyze a text and then provide user-specific suggestion to change your writing style. Both of these tools are available on our website and they're open source, so feel free to look at them and help them to improve these tools. So in this talk, we wanted to see that all the stylometric tools that we are working on in our lab and all the other linguistic tools that are already available, if they can be used to make sense of a real-world data set. In particular, we wanted to see that if we can identify people using their writing style in a real-world setting and identify a topic of their discussion. And as a real-world data set, we use the online underground markets. This is an overview of my talk. At first, I'm going to explain the data set we used. After that, I will talk about the analysis we performed and discuss our results. Then Aylin will take over and talk about the limitations and challenges we faced. And at the end, she will briefly discuss Anonymouth. So underground markets are the places for trading stolen goods like stolen passwords and account numbers and email accounts, all the stolen email accounts, and the tools that can be used to steal these credentials from people, tools like exploits and malware repackaging kits and phishing kits. Many of you might remember this incident that happened in June this year, where a user in a Russian forum said that he hacked and uploaded over almost 6.5 million passwords from LinkedIn. So the underground forum where this incident happened would be an example of online underground market. So obviously this data set is very interesting because this data set can, analyzing this data set, we can have an understanding of how cyber underground ecosystem work. We can have key information about who controls a given bot and who has a certain information, who maintains a certain tools, and the size and scope of this underground network. Many such underground network data sets get leaked at various points, and people have done manual analysis on them. For example, I took this blog post from Krebs on Security, where the journalist analyzed the leaked chat conversation of Spamit Associates. Spamit is a cybercrime business that pays spammers to advertise rogue internet pharmaceutical sites. So from the conversation of Spamit and Rostock botnet. So Rostock botnet was one of the biggest spam botnet that was responsible for most of the global spam emails. So Brian Krebs, writer of this blog, he manually analyzed the chat conversation of Spamit and Rostock botmaster to find the real-world identities of these botmasters. So we wanted to see if we can do a similar kind of analysis automatically using the linguistic tools we have. There are primarily two underground networks. The first one is the IRC channel, and the second one is web forum. In this talk, we are only going to focus on the web forums. We had the leaked data set of 5 forums. The first one was AntiChat, which was a Russian forum. We had 2 English language forums, Bad Hack and Black Hat, and we had 2 German language forums, Cutters and Lead Crew. So how did we get this data set? This data set were leaked by anonymous people, and when we collected them, they were publicly available on RapidShare. Okay, so let's look at the statistics of these forums. This graph shows number of active members and lurkers of this forum. Active members are the people who actively participate in the forum, and lurkers are the people who just register in the forum but never post anything. Member-wise, AntiChat was the largest forum we had with over 25,000 users. And Lead Crew was the second largest one with 9,000 users, and the other forums had around 5,000 active users. So typically, this is how a transaction happens in these networks. These forums are usually closed door, so you have to register into the forum to be able to interact with the people in the forum. So usually a person interested to buy or sell something would register into the forum, and then he would post a message like this. I took this from one of the forum posts. Here, the person has 22.5 million emails, and he was interested to sell them. So after the person publicly announced the thing that he wants to sell, people interested to buying them would contact the person via private messages, and they can do the whole transaction in the private messages inside the forum, or they can exchange ICQ and email addresses and then do the transaction outside the forum. So from here you can see that the public messages are mostly for advertising, what you want to buy or what you want to sell, and private messages are where most of the conversation and transaction happens. So let's look at the number of private and public messages we had in the forums. Message-wise, also AntiChat was the largest forum, and Lead Crew was the second largest one. From the statistics, you can see that this data set was really large. With just in one forum, we had like thousands of users and millions of messages. So manual analysis of this forum is very hard. And on top of that, each forum was in different language. We had Russian language forum, and we had German language, and we had English forum. So for one person analyzing in different language, forums from different posts from different languages is very hard. But as I will show later in the slide, that if we can easily automate this process and identify people much faster using automated analysis. We did three kinds of analysis on this data set. The first one was interaction network analysis, where we created a graph of private interaction among members in the forum. And the second one was we tried to create profile of people using their writing style. And we wanted to see if we can identify them using their writing style. And the third one was topic discovery. Here we use automated topic modeling to find an interesting subset of the dataset. So for interaction network analysis, we created a graph for each forum where each user was represented as a vertex, and each private interaction between the user was represented as a directed edge in the forum. So our goal for doing this interaction network analysis was to see the structure of the interaction among the members in the forum. That is, who is connected with who is talking with who, and identify central members in the forum. So after you create a graph of each forum, there are many cool ways to find the central nodes in a network. We used eigenvector centrality. Eigenvector centrality is a way to find influential nodes in the network. So higher the centrality score, it means that more influential you are as a member in the forum. So this is one of the interaction network graph from AntiChat. Here, bigger nodes represent more influential users, and the darker nodes represent the people who send or receive a lot of messages. So here you can see that there are only a couple of big nodes. There are only a couple of influential users, and most members in the forum are only interacting with these big users. And here also you can see that the darkest node that is sending a lot of messages is very small. So it means that this node sends a lot of messages to a lot of users, but nobody is interacting with him. So this is an indication that this is maybe an automated bot to send automated notification messages. So graph analysis is a way to reduce your set of people that you want to look at. So after you remove the non-influential members from the graph, you end up with a very dense graph of influential members. So this graph we got from AntiChat. Here you can see that the influential users in the forum are very highly connected with each other. We had ground truth data set of who runs a forum for some of the forums, and we saw that this eigenvector centrality really brings out the people who are running the forum. So it's a very quick and automated way to find out the people who are running the forum. We noticed the same kind of structure in almost all the forums except BadHack. In BadHack, we saw that there were only 6 influential members and everyone else was just connected with them, but there were no connection between these influential members. Our second analysis was member profiling using writing style analysis. In our previous research and other research in stylometric analysis repeatedly showed that everybody has unique writing style. So we wanted to see if we can identify members of these forums using their writing style analysis. Whenever I say that everybody has unique writing style and I can identify you using your writing style, people look at me very skeptically and they say, no, my writing style is not that unique, and even if it is, you cannot really find me. So you don't have to trust me. We have this cool tool, JStylo, that is open source and that is available in our website. I would encourage you to download this tool and play by yourself and see how unique you are. JStylo comes with a built-in dataset. So you can either take your own writings and see if JStylo can find how unique you are in the dataset we have, or you can create a dataset of you and your friends and see how different you are from your friends. This is a graph that shows evaluation of the current writing style analysis methods. I took this from last year's talk of Mike's. And here you can see that with 40 users, our writing style analysis methods are over 75% accurate in identifying a member. So they're very good in finding people. So this is how we profile the user in our forums. At first, we combine all the messages that a user posts in the forum, and then we find the members with enough text. I'm going to explain how much text is enough for doing writing style analysis later in my talk. After that, we use JStylo to extract linguistic features, and then we train the classifier to model a member. And in the end, we evaluated our approach to see how well we are doing. How much text is enough? So when we are modeling a classifier to identify a member, we need to train the classifier with enough text of that user. And we wanted to see how much text is enough to correctly identify a user among other users. Here, this graph shows, x-axis of this graph shows that number of training documents, number of 500-word training documents were used for training, and the y-axis shows the accuracy of our classifier. And each line here shows one forum. Here you can see that as we are adding more and more documents for the training process, the accuracy was increasing. And we found that after we added 5,000 words, the accuracy did not improve as much. So 5,000 words are the minimum number of documents we need from a person to correctly identify him. We used 6,500 words because 6,500 words is a golden standard for writing style analysis. After we have enough text of a member, we use JStylo to extract features. Now let's look at what are these features that uniquely identify a person. I took this example from Cutters. I don't speak German, so this is what Google Translator thinks it means. And you can see that it's not very good. Little story behind this message. This user was a common user of both Cutters and Lead Crew. So when Lead Crew was down, he was confused and he was asking other people that is Lead Crew really down or it's just they're having DNS problem. From each messages like this, at first we extract frequency of different n-grams. N-grams are like each word would be an unigram, word unigram, and each character would be a character unigram. So we have a frequency of character bigrams, unigram, and trigrams, and word bigrams, unigram, trigrams. Our second feature was frequency of different punctuations. Our third feature was frequency of special characters. And we call this feature set language independent feature set because these features are not specific to any language. You can use them for any language. We also had language specific feature set. So on top of the language independent feature set, we added function words, frequency of different function words. Function words are the words that are not content words. For example, in English, function words would be the prepositions and articles. And we also added perso-speech for each language. We had perso-speech for English, different perso-speech tagger for English, German, and Russian. Now, a stylometry classifier can identify a person among a lot of people because when we are writing language, when we are writing something in a free form, we make a lot of linguistic choices. And if you combine all these linguistic choices, it seems very different. To a linguistic classifier, we seem very different from other people. And this is how the linguistic classifier works. But in our data set, we noticed a lot of product information because these are the forums where people were sharing product and people were they're selling and buying products. So what's wrong with this? The problem with this product information is that if two members are sharing similar kind of products, to a linguistic classifier, both of them would look exactly the same. So we won't be able to identify them. So we created a very simplistic product identifier to identify the product information and separate them from conversation so that we can build a better model of each user's writing style. Our product identifier is based on two very simple observations. The first one is that the product information has a very repeated pattern. And the second one is that conversation usually always has verb. So based on this, we wrote this product detector. At first, we tag all the text with their perso-speech, and then we try to find repeated pattern in the document, and after that we checked for verbs. If the document has repeated pattern but no verbs, then we would consider it as a product and remove it from our data set. And if there are repeated patterns but it has verb, then we'll consider it as a conversation. Maybe the user was only repeating himself. This is how we remove the product information from our data set. Now let's look at how well our classifier does in identifying people. So this graph shows our results of authorship identification on different forums with both language specific and language independent features. Here you can see that language specific features work better than language independent features. And the second thing is that we saw for one forum, accuracy on the private messages were much better than accuracies on the public messages. We think that the reason for this is that private messages are more conversational, whereas public messages were mostly advertisement, and public messages were short and they had very specific format. That's why our results were worse in public messages. Now, in our data set, we noticed that there were a lot of people that had duplicate accounts, but we didn't have any ground truth of the people with duplicate accounts because people were using different IP addresses and different email accounts, so we couldn't find them. So instead of doing exact attribution, we wanted to do a relaxed attribution. So in exact attribution, when you give the classifier a text, we ask this question, that who is the author of this text, and the classifier would find an author of this text. But in relaxed attribution, instead of finding the exact author, we would ask the classifier to find the top 10 possible author of this document, and the classifier would find the top 10 people who the classifier thinks are similar to this author. So using the relaxed attribution, so this is the graph of our relaxed attribution results. Here the x-axis shows the number of possible members we considered, and the y-axis shows our accuracy. Here you can see that our accuracy improves at least 30% when we try to find top n users instead of the exact users. So this method is very useful to identify number of possible suspects and minimize the set of suspects that you need to look at. And later in my talk, I will explain how you can use this to find different identities of people. Now, finding a member in one forum is interesting, but what would be more interesting is that if we can build a profile of a user based on his post in one forum and then try to find him everywhere else on the web. So in our data set, we just had multiple forums, so we wanted to do this analysis on different forums. We found the similar members based on their email addresses on different forums, and then we trained our classifier on the post from one forum and tested it on the post from a different forum. In our data set, there were only Carters and Lead Crew had enough people who were enough common users, and among them only 39 users in Carters and 83 users in Lead Crew had enough text to do the authorship analysis. Here in the graph, that shows how successful we were in finding people in different forums. You can see that when we were trying to do the exact match, our result is very bad. It's around like 20%. But when we were trying to find top 10 people who were similar to this user, our accuracy goes up to 70%. Now, let's look at the people who the classifier thinks could be the possible suspect of these people. Maybe they can tell us something about this user. Maybe they're the alternate identities of this user. To see this, we created another graph where each user is a node, and there will be an edge from Alice to Bob if, when we are doing relaxed attribution, Bob comes up as one of the possible suspect of Alice. We didn't have, as I said before, that we didn't have the duplicate accounts on the forum dataset, but we recently got the chat conversation of Spamit associates, and there we knew different accounts of the same person. So we did the similar analysis on that. So this is the graph we created. Here, all the names are not the real names. They are all anonymized. So if we do relaxed attribution on Alice and create a graph, and then we do relaxed attribution on the ICQ of Alice, and then we do relaxed attribution of the other identities of Alex, we'll see a complete graph between all the identities of Alice. So in a large network, if you look for the complete graphs, that is a very good indication of the alternate accounts of this user. Our last analysis is topic discovery. Using topic discovery, we can find the predominant topic of a forum. It's interesting because, as I showed you before, that our dataset was huge, and using topic analysis, we can minimize the dataset to a very interesting. We can find a very interesting subset among the dataset, and then do manual analysis on it instead of doing manual analysis on the whole dataset. And it can also help us find relevant people who are talking on a specific topic. And topic modeling also helps us understand trends. For example, if you do topic modeling from messages in different forums, you can see how different tools are popular and unpopular at different times. For our topic analysis, we used a latent Dirichlet model allocation, LDA. So how LDA works is that LDA assumes each document is made up of words taken from different topics. For example, this document could be of 3 topics. There could be one topic about bulk mailing. There could be one topic about advertisement. That would include words like advertise and promote. And there could be another topic about hosting companies, servers, and hosting accounts. So using LDA, we can find the words that are related to a specific topic. We used LDA to find different topics and number of messages that are related to a specific topic. And after we found the topic and the words related to the topic, we used manual analysis to understand what kind of product or what kind of service these words belong to. And on average, we found 200 to 300 topics per forum. These are the topics that we discovered from our forums. So here on the Carters, the biggest topic was carding, and selling of other accounts. And here we saw that people were using PaySafeCard, uCash, and web money as a currency. On Lead Crew, the biggest topic was crypting services. So crypting is a way to repackage your malware to evade antivirus detection. So that was a very popular topic on Lead Crew. And the second popular topic was anonymity services. So people were sharing proxies and VPNs and socks, things like that. On anti-chat, the biggest topic was password cracking tools. It was a Russian forum. And people were using web money as currency. So Black Hat was a search engine optimization based forum, and we noticed the biggest topic was Black Hat SEO tools. And there we also saw many tools that are specific to blogs, YouTubes, and social networks. So now Aylin will go over and talk about the challenges we faced and the limitations of our approach.
Thank you, Sadia. Hi everyone, I'm Aylin Caliskan Islam and I'm a second-year PhD student at Drexel University, and my advisor is Dr. Rachel Greenstadt, and I work at the Privacy, Security and Automation Lab. Sadia showed you all these nice results, cool graphs, but when we were trying to get these, we had a lot of challenges, and in our study we have many limitations, and we are going to take these into account in our future work. So I'll talk about these, and then we will draw out conclusions. And at the end, I'll mention the tools that we developed in our lab, especially on Animat. We had 4 main challenges. First of all, Sadia showed you that we have millions of messages from tens of thousands of users, and these messages contain microtext, and the microtext is also multilingual. And besides having these properties, they contain product information embedded in the text. And our last challenge was users that had multiple accounts within forums or across forums. As an example of microtext, this is a German message, Bratzers heute Morgen ging's noch. And it's a short writing, so it's difficult to understand it or train a classifier on this short message. And we also get informal and conversational style messages like laugh out loud, ... Nice post. And such text is also multilingual, and since we are trying to experiment on our data in machine learning, we need features. And if it's a multilingual text, we will require multilingual features, and these could be language-specific part-of-speech taggers or language-specific function words. And from our previous research, we know that many authorship tools are designed for English, so if the language is English, they work more efficiently. And from my previous research, I know that if you translate a foreign language text into English, you will get higher accuracy if you perform authorship attribution on it. So we decided to translate Carter's Public into English to see how we can profile members. Is it going to be any better? And if we look at the first bar on the left side, this is the untranslated version of Carter's Public, and we identify users with 67% accuracy with a language-independent feature set. But after we translate this data set and still use the language-independent feature set, our accuracy rises to 75%. And on top of this, if we use English-specific features, such as right prints, we get the highest accuracy. So we had more than 10% increase in our accuracy just with translating the data to English. But we know that our data set is very large. We have millions of messages. So if we want to translate these messages all to English, first of all, we need to automatically detect their language in order to perform batch translations. And even if we are able to detect the language, then we will need to translate them in good quality, but unfortunately, we don't get very good quality translations. And here, the examples I will show you belong to Google Translate, but as a lab, we have access to a wide variety of language detectors or translators, but they don't perform any better than Google Translate. Oh, by the way, in all the examples, they'll be all anonymized, and if you see any links or account information or URLs, none of them work. They're all anonymized. And here we have this German message, again from a German forum. And we are trying to detect the language on Google Translate, and it's detected as English. And let's look at another case. We have another sentence. This is a message from a Russian forum, and it's in Turkish. The language is detected correctly, but when we look at the translation, and I'm a native Turkish speaker, so I can tell the difference, the translation doesn't directly correspond to what it means in English, and on top of it, we still have 3 Turkish words left in the English translation. Okay, so we had multilingual text and microtext, but on top of it, we had product information included in this text. And this is also problematic for machine learning. So if you are using even language-independent features such as engrams, again, we won't be able to develop a very complete and good model for each author when we are training our data. For example, when we look at this Russian message example, we see the first part that looks like conversation, and then we get some product information. So if we are trying to train our classifier, it would contain a lot of engrams that have numbers and information coming from passwords and also punctuation, like the @ And this doesn't really represent the writing style of this author. And why would product information cause challenges in our text? We have this huge data set, and there are a lot of different types of information, product information, and different products. And we want to separate these products because we want to analyze the conversational part. That's where the user actually puts their linguistic style, and that's how we can profile members better. And we need a method to detect all these different products. Sadia mentioned the method that we had with the POS tagger. So with the part of speech tagger, we are using a generic tagger. And looking at the forum, for example, AntiChat is a Russian forum. Therefore, we would use a rule file for Russian part of speech. And then, after looking at text and tag all the words, if we see a pattern, and if that pattern also doesn't contain verbs, it will be tagged, that message will be identified as a product or the part of that message. And we have all these different types of products, like the main ones would be exploits, copyright infringement, credit cards, bank accounts, email accounts, all possible kinds of online accounts, bank drops, shipping, delivery services, and drugs. And these all have different formats, and we need to detect them in an efficient way. For example, an exploit will contain a lot of code, and this is copyright infringement format. And credit card information, bank account information, a lot of more accounts, online accounts, and bank drops. And here is an example for shipping and delivery services. So this guy is selling skimmers, which is actually a physical product for ATMs. And he has this format, and this is an example of a skimmer that was found in Ireland. And it looks exactly like an anti-skimming device when you look at it. So it was difficult to find this one. And for drugs, this is a different format again. And our last challenge was caused by users who had multiple accounts within forums or across forums. Within forums, it's not allowed to have more than one account. So these users signed up with different IPs and email addresses so that people cannot, or their accounts cannot be identified and they won't be banned. And this is causing problems for us. Now we cannot identify them. We don't have the ground truth to find them. And in supervised learning, since we consider these as different users, our authorship attribution accuracy and also our social connection graphs suffer due to this lack of ground truth. And in our experiments, we had some limitations in general. Sadia talked about how many documents, 500 documents we need in order to perform efficient authorship attribution. And we know that it's at least 5,000 words. But we used the gold standard, which was 6,500 words. So even though we started with tens of thousands of users in the forums, at the end, after eliminating the users that had less than 6,500 words, we were left with only hundreds of users. And we are also anticipating forums with less well-known languages in the future. And this will cause more problems in maybe identifying the language or again translating the language. And we know that we need to separate all the conversational data from product information so that we can profile members better. And right now our method is working well, but we need improvements so that we can detect all different kinds of products out there in these forums. And for example, this is a false positive product detection. Again, this is a Turkish message. It's talking about an MSN cracking tool, and it's explaining the feature in a very informal and funny way. And this is detected as a product, but this is in a Russian forum. So in a Russian forum, the POS tagger used the Russian rules, and all the words were tagged as not a foreign word. And it made a pattern, text pattern, and the text pattern didn't contain any verbs. They were all foreign words. So it was detected as a product, which is not correct. That's why we need a better product detector. And we can draw the conclusions that we applied stylometric analysis to this huge real-world data set, and it's also used in live practical data set, and this has been very rarely done before. Some cases did some analysis in manual ways, but we are trying to automate most of the process. And we saw examples that short lead speak cannot be easily translated. And also applying stylometry to big and semi-structured data is a very difficult thing, even though we are getting good results with all these tweaks. And we raised our accuracy to actual authorship attribution quality, which is performed on clean data sets that contains nice essays and clean documents which are all structured. And we can tell that, especially when Sadia explained how we decrease the number of suspects with relaxed attribution. If you're interested in a particular person, we can still be able to identify at least a set of suspects, and those can also be multiple account holders. And we are able to see predominant topics in forums. And this minimizes the manual analysis time that was done in the past, like the example Sadia showed about Brian Krebs. And for future work, we are willing to use more user-specific features and temporal information. User-specific features would be, for example, some users just decide to leave their signatures at the end of a message. So if we use that as a feature, it will have a very high information gain and it will be very strong. And also we would like to use temporal information. For example, some hackers, they always decide to, I wouldn't say hackers, some members of these forums, they decide to always log in from the same location, from the same time zone, and they come home after work and they always write messages in the evening. So that will also be a strong feature. And we would like to, after identifying the members, we would like to add the topics that they are related with or they are interested in. And this will give us a bigger picture of these members and the forums. And we need to identify the multiple account holders for the sake of the ground truth. And then, as Sadia explained, the main venues for underground economy is the internet relay chat and also these forums. So we would like to combine these data sets so that we can have a bigger picture and a more complete information about the members. And from beginning to end, we want to automate this process, but there are many steps. And so after we take all these IRC chat logs and the forum data, we would like to identify the users that have enough text, separate the product information, translate the text, then profile the members, perform topic analysis, and also see their interaction networks. And in summary of this lecture, Sadia talked about how we profile members of the underground economy and how we need to do product information and extract the products from the text. And we discovered topics that were being discussed by members or that were predominant in the forums. And we showed the interaction network analysis where we see the influential users or how members interact with each other. And then I talked about the rest of the problems that we faced. In the first part of the lecture, Sadia said that we used JStylo to do the member profiling part. So this tool was released in last year's CCC, and here is the link to it. If you want to take a look at it, feel free to go to the link. And this authorship attribution framework was powered by JGAP and VECA. And it helps you, like, if you have a 500-word document and we have a corpus that's available for you, you can see how unique your writing style is. But after JStylo, on top of it, we developed our authorship anonymization framework, which is called Anonymot. Again, this was released in last year's CCC. And you can have more detailed information about it in last year's lecture. So, from this lecture, we can tell that even if our text is not clean, your writing style can still give you away. And if you use Anonymot, and let's say that you have this 500-word document and you want to publish it somewhere, you don't want anyone to know that it was written by you. You might publish it to one of these forums or just to a website. And to Anonymot, you give this 500-word and also at least 5,000 words of your other writing, and it will identify the changes that you need to make in order to anonymize your writing. And it will give you all the details for these changes, like it will tell you, you need to change this letter, you need to go to this specific sentence, you need to change this punctuation. And again, both of these tools, JStylo and Anonymot, are in a jar file on our website. So if you just want to play with it, you can download it from our website. But these are also open source projects in Git, and here is the link to Git if you want to clone the project. And especially for Anonymot, we are still developing it. So if you would like to help us, or if you have any comments, please feel free to download it, take a look at it, and let us know. And here is the list of all our contributors. And feel free to contact us if you have any questions. And for the last link, that's the address to our research lab at Drexel University. If you're interested in our research or the other projects, you can go there and see all the publications we have. And thank you very much.
Yeah, thank you very much for this very interesting talk. So we can now go on with questions, and if you have a question, just get up and stand behind the mic so we can hear you. We will start with a question from the internet. Signal Angel.
So yeah, the internet has many questions, and many about languages mostly. So first question is, how do you approach? How does your approach work with Chinese language, or did you have any specific problem with specific languages?
So for Chinese language, so Chinese is a very difficult language to work with. First of all, Chinese language doesn't have any like word separation, and it's a research problem. Word separation in Chinese language is a research problem. So we haven't looked at any Chinese underground forum yet, but there are word separation research tools, and there are tools for Chinese parser speech. So if we have a forum, if you have a data set on Chinese forum, I would love you to, I would love to have that forum so that we can analyze it, and we can give you a better answer that how we handle that.
Okay, next question over there.
Hello. All right.
Hi.
Thank you for your talk. It was really interesting, and I learned a lot. I have one question. I have two questions actually. So the first question is: did you consider blueprints that people copy and paste to messages? Because I can see, for example, I get a lot of offers, probably reply once and then copy and paste this message to all the others. So did you ever consider like text similarity in the responses?
No, we did not consider that. Yeah, so that might be one reason that might be affecting our results. But it's like, what do you mean by replying same messages?
Well, I mean, like I say, I sell credit card details, okay, and then people say, how much do you want? And maybe I have a, prepared response that I just copy and paste, because there'll be multiple people asking me that question, so send a response.
Okay, but So like in the public messages, maybe people can do that, but in the private messages, like people have specific questions and they have specific answers.
And if it's too repeated, it might be detected as a
Oh yeah. So we had another research is that you can, if a user is always repeating a message, you can compress all the text from his text and then find out the repeated pattern and then delete that.
I see.
But we didn't apply that in this research. Maybe we'll do it in the future research.
All right. Yes, and then the other question is, maybe it's a little non-technical, but I wonder, because I see like ethic, let's say, impact happening from the availability of the technologies and tools that you do. And I wonder if in your research community, machine learning and text classification, is there any discussion about ethics, for example, targeting people? We learned yesterday that, I can see that, these technologies would be really useful for a huge database that the NSA or whatever collects. So I was wondering if there's any moral debate going on in your research community.
Well, that's one of the reasons we are creating Anonymous, so that people who wants to hide their writing style in saying something, they can use Anonymous, and that's. Yeah.
And also JStylo, like if you play with it, you'll be able to see that you can be easily identified among other users. So we're not really trying to identify people. We are just trying to show that this is possible with the technology that we have.
Sure.
Yeah, like tools like this. Hello? Yeah. So these tools are to make people aware that these things can happen,
right,
so that like people can be aware when they talk on the web. Thanks.
Okay, question over there.
Yeah, so you had about recognition rates 70–80%. How exactly are these numbers to be understood? So 80% recognition, what does this mean? So out of this couple of hundred users you identified as the single one, or?
So, first of all, we train on a data, right? So, as we said, we need at least 5,000 words. After that, after our classifier is trained, we give it documents. Let's say that we have 80% accuracy. And we gave it 10 other documents that belong to this one author. And if 8 of those documents were identified as they came from this author, it would be 80% accuracy. And this is supervised learning, so we already knew that.
Yeah, okay, I'm sorry. So yeah, 80% accuracy means that if you have 100 users, we can identify 80 of them. That's what it means. If our data set is like, data set consists of 100 users, we can at least identify 80 of them with very high accuracy. Yeah.
Based on one text?
No, so this result is that we took one text and did the classification, and took another test, did the classification, and then the 80% is the average of all the results we got. So these are this was done repeatedly on different text, and then this is the average of our results.
Okay.
You go to the slide if you want.
So what is that buzzing sound going on there right now? Okay. Signal Angel?
So next question from the internet. What tool did you use to actually translate to English? Did you just use Google Translate or some other tool?
You translated it.
Yeah. For this, we use Bing because because Google Translator doesn't have any. Google Translator, you have to pay for.
Yeah, you should take mine. It's not working at with the.
Yes, hi. For this, we used Bing, but we also have access to some very exclusive translation tools that we are planning to use in the future. Yeah, but for this project, we used Bing. We didn't use Google because Google API is not free, and Bing API was free.
Okay, hi. I got at least 2 questions. One question is, you told of the language-independent features. mainly punctuation and stuff. And I just thought about Spanish, for example. As far as I know, in a Spanish question, you have a punctuation mark in the front and in the end of the sentence. So shouldn't be the punctuation probably in other languages be different to, well, those you studied, English and German and stuff?
So if the punctuation is in the front, is it in
Question mark
reverse?
turned up and upside down,
Oh,
I think.
okay. Yeah, we didn't consider those. Yeah, because we didn't have to. We didn't have any Spanish data set, but the punctuation set we used is kind of the smallest subset of most of the languages.
Yeah.
Maybe so that would be a language specific features, and that we have to include separately, but we didn't do it here.
Okay, and digging deeper there, do you think it is similar, or did you study it in detail? Well, just took languages or took text in Russian, German, English, well, filtered it for punctuation, and okay. You did say no, or did I misunderstand you just a second ago?
No, I didn't understand your question.
Ah, okay.
Yeah.
Take text
Okay.
of the same length from different languages.
Okay.
Filter it for punctuation and look whether the rest is of the more or less same size.
Oh.
Did you do something like that?
No.
Or do you just estimate that the, well, punctuation, for example, punctuation amounts within a text is definitely language independent?
Yeah, we just used one set for all the languages, all the set we had. We didn't do this manual analysis.
Okay.
Not manual analysis. We didn't do like specific forum analysis. We just used one set of punctuations for all.
Okay. And a last short one, you talked about lists of topic within the topic detection, and you had names for the topics.
Yeah. Oh, we came up with the names. So the topic words were like for cardings. The topic words would be like credit card, password, email account, and buy, sell, things like that. And so we looked at like 20 topic words, and then we came up with the names.
Okay.
Like for example, so account, credit card, passwords, email, they are possibly, they should belong to carding.
So you started with vocabulary lists and just had a look.
We manually analyzed the list and then came up with this.
Okay.
For example, we had like the crypting services. We had topics we had words like FUD crypting and exploits and stealer, things like that.
Yeah.
So those are clearly belong to the crypting services.
All right.
So that's how we came up with these names.
Okay, thanks.
Yeah, thank you.
Okay, next question over there.
Hello.
Yeah.
Am I on? I don't seem to be. Oh, there we go. Hello, thanks for a very interesting and somewhat scary talk. I was surprised to see that you needed a translation phase. Is anyone doing any work of just treating the languages as streams of symbols and saying, well, this person tends to use this symbol followed by that symbol and then with another symbol, and then you wouldn't have this problem of forums in strange languages? You just treat them purely, or is that impossible?
No, so we actually used symbols. For example, the first feature we had, that was the frequency of n-grams. So n-grams were like every characters. So we had character bigrams. So a character bigram would take every 2 words and look at their frequencies. So this way, if we have any strange language, we can still do stylometric analysis on them, because we were looking at symbols. We were looking at characters, not like alphabets.
So was the language stage just to figure out what people were saying, or was that for the... I didn't quite understand why the language stage was that. The translation.
Okay. The translation part. Okay.
Why translate it? Because you could just treat it as a stream of, as you say, a stream of characters.
Oh, okay. So the problem with this, only if you look at stream of characters, so if you are talking about credit card information, buying, selling, and I'm also talking about credit card information, then you and I will have a lot of common words. And then it's hard for the classifier to separate us. But there are some language-specific features, like the parse of speeches, or like the function words. Those are language-specific, but that would create real difference between you and me, even when we are talking about the same topic. but we are saying it differently. This is why like language-independent features are necessary, and we translated it because there are a lot of authorship recognition work and linguistic works are done in English, but not so much in other languages. So we wanted to see that if we translate all of them to English and then do authorship recognition, if we can we get better accuracy? Can we identify people more accurately?
But most of the results are just on
Yeah, yeah. Okay, yeah, thank you.
Okay, Signal Angel.
Okay, next question is from Twitter. So, what was the tool you used for influencer analysis? So,
Influence? Oh, we used eigenvector centrality. We calculated eigenvector centrality score of each node.
okay.
And if the score is high, then we think that... So eigenvector centrality is a measure of influence of a node in the network. So if the score is high, we would consider it as a high influential node.
Okay, I think the question was, is it a custom tool or something?
The tool, the specific tool?
You wrote the tool from scratch? Or?
Oh yeah, we just use eigenvector centrality. It's just a formula.
Okay.
Yeah.
Okay, question over there.
Hello. Oh, I have two questions. The first one is, have you tried using your analysis on public forums, for example, to identify covered guerrilla marketers or similar things?
So no, we did not. First of all, no, we did not.
And second question, the techniques that the anonymous tool uses, can they also be used to impersonate other users?
Yes.
Probably, but currently we have this rule is that you have to provide sample text of at least 3 users, and then Anonymous will find how different you are from those 3 users and take the average suggestion. For example, if the 3 users you have in your network, in your data set, if they all use like short words and you use very long words, then Anonymous would ask you to change the size of your words. But you can choose the same author 3 times, and in that case, Anonymous would help you to impersonate people. But yeah, it can be done like that.
Okay, your question?
I was wondering how important the context of the training data is, especially when comparing, let's say, different kinds of data sets. For instance, if I have someone's thesis or a paper of him, would I be able to find him on a forum or vice versa?
Can you repeat the question? I the mic again. Oh, hello. Okay. Yeah.
I was wondering if you have someone's paper or a thesis of him, like a lot of training data, would you be able to identify? Sorry?
Okay. Oh, yeah. So if I have someone's thesis, would I be able to identify him in the forums?
Yeah, in the forum, because a thesis is a
very different style.
Very formal, and you care a lot for grammar and stuff, and on the forum it's more informal, you know, and you may use lead speak and stuff like that. So how important is context?
So context is very important, but so there are features like function words. So function words are the features that are independent of context, and there are research that shows that function words are very specific to the users. And even if you write a thesis, you'd probably use the same amount of for that, and when you're writing a chat messages. So probably your function word users would be very similar in both cases. So maybe it is possible to do that.
Thank you.
Yeah.
Internet?
Yeah, the next question was very similar actually. So, did you notice a difference between writing style between like IRC and emails or things like that? But I guess you just answered that.
Oh, okay.
So I can go to the next question. did you check your anonymous, and so did you check anonymous against other stylometry tools or just against your own tool?
So the JStylo has many tools, many authorship recognition tools, and we have many tools, and you can add more tools on it. So JStylo is not just one authorship recognition tool; it's just a bundle of many authorship recognition tools. So we use JStylo against anonymous, and we are planning to add more and more state-of-the-art authorship recognition tool with JStylo.
Okay, your question.
Thank you for sharing. Oh, works. I find it surprising that translation turned out to be reasonably good for such a task. Did you do some comparisons between the languages? For example, what about Russian that are hardly to translate because it's morphologically rich, and what about smaller languages? I don't know, Polish, Romanian, Czech, something with not so many speakers.
Probably Aylin can answer that because she did.
Yeah, so far in our studies, we haven't looked at Russian or Polish yet, but we looked at German and Dutch, French, and such languages. But we are trying to extend the list of languages and study it, like different languages from different language families which have different grammar structures.
So I suggest maybe in further research you need to add some comparative numbers because I think it's interesting.
Yeah,
thank you.
That's some future work.
Okay, the next question is over there.
Okay, you showed data that shows how accurate your detection is based on how large the classifier dataset is. So how large the dataset is that was used to create a classifier. But do you also have data based on how large the dataset was to which the classifier was then applied? So basically, how large does a message have to be reliably identified?
So what we do is that we combine all the messages of a user, and then we divide them into 500 words chunks, and then we did that analysis that I showed.
Okay.
And in order to come up with the 500 words, after training the data, we took different documents that had from 400 to 600 words, and the highest accuracy was reached from 500 words. That's why we are choosing 500 words.
Yeah, so if you have one document which is like 100 and another document which is like 2 or 3, we combine all of them and then normalize it into like 2 or 3 chunks. So the length is normalized.
Okay, can I ask a second question?
Yes.
If it's short, yeah.
Yeah, you showed that in the datasets of the forums, you basically reduced the dataset to the, I think, 50 most important users.
Yeah.
And did you apply basically another run of your software after you filtered those users out based on the ground truth, or did you filter those users based on the results of your software and then apply the software again?
Can you explain it again? Sorry.
So basically you have this set of users which you group based on users, once based on the ground truth and once based on your software. And
no. We did it based on our ground truth.
Okay.
Yeah, because we had no other way to find how well our classifier is doing other than ground truth.
So essentially the networks you get from just the 50 users and the complete data set are the same except that you take users away.
What? Can you say it again?
Sorry. You had those data sets of the forums where you saw the connections between the different users.
Yeah.
And is the reduced data set of just the 50 top users the same data set with just the other users removed, or is it somehow different?
So we ran the analysis. So we ran analysis on the top influential users and also random 50 users and also on all the users with sufficient text.
Okay, so it was 2 different identification runs.
Yeah. There are different identification runs.
Okay, thank you.
Okay, theoretically we have all night for questions because it is the last talk in this hall. But I think people are getting nervous. So the remaining questions, maybe you can stay here and discuss with the talkers, and the rest of you can leave then, of course, after you have picked up your trash or someone else's, which is lying under your chair. And I also have an announcement. We still have room for lightning talks tomorrow and the day after. So if you have a topic you would like to introduce us to, or you would like some help and talk to people about, feel free to contact Nick Farr about a lightning talk. Yeah, thanks again.
Hi everybody, my name is Sadia Afroz. I am a PhD candidate at Drexel University. Aylin and I are going to talk about Stylometry and Online Underground markets. This work is a joint work which is done in collaboration with Ariel Stollerman, our advisor, Rachel Greenstadt, and Damon McCoy from George Mason University. So this would be our third talk at CCC. We might get the first talk at 26C3, where he introduced this concept of adversarial stylometry, which shows that if you change your writing style, authorship recognition algorithms won't be able to recognize you as the author of a document. In last year's CCC, we presented two tools, JStylo and Anonymouth. JStylo is the authorship recognition tool, and Anonymouth is the authorship anonymization tool that uses JStylo to analyze a text and then provide user-specific suggestion to change your writing style. Both of these tools are available on our website and they're open source, so feel free to look at them and help them to improve these tools. So in this talk, we wanted to see that all the stylometric tools that we are working on in our lab and all the other linguistic tools that are already available, if they can be used to make sense of a real-world data set. In particular, we wanted to see that if we can identify people using their writing style in a real-world setting and identify a topic of their discussion. And as a real-world data set, we use the online underground markets. This is an overview of my talk. At first, I'm going to explain the data set we used. After that, I will talk about the analysis we performed and discuss our results. Then Aylin will take over and talk about the limitations and challenges we faced. And at the end, she will briefly discuss Anonymouth. So underground markets are the places for trading stolen goods like stolen passwords and account numbers and email accounts, all the stolen email accounts, and the tools that can be used to steal these credentials from people, tools like exploits and malware repackaging kits and phishing kits. Many of you might remember this incident that happened in June this year, where a user in a Russian forum said that he hacked and uploaded over almost 6.5 million passwords from LinkedIn. So the underground forum where this incident happened would be an example of online underground market. So obviously this data set is very interesting because this data set can, analyzing this data set, we can have an understanding of how cyber underground ecosystem work. We can have key information about who controls a given bot and who has a certain information, who maintains a certain tools, and the size and scope of this underground network. Many such underground network data sets get leaked at various points, and people have done manual analysis on them. For example, I took this blog post from Krebs on Security, where the journalist analyzed the leaked chat conversation of Spamit Associates. Spamit is a cybercrime business that pays spammers to advertise rogue internet pharmaceutical sites. So from the conversation of Spamit and Rostock botnet. So Rostock botnet was one of the biggest spam botnet that was responsible for most of the Member-wise, AntiChat was the largest forum we had with over 25,000 users. And Lead Crew was the second largest one with 9,000 users. And the other forums had around 5,000 active users. So typically, this is how a transaction happens in these networks. These forums are usually closed door, so you have to register into the forum to be able to interact with the people in the forum. So usually a person interested to buy or sell something would register into the forum, and then he would post a message like this. I took this from one of the forum posts. Here, the person has 22.5 million emails, and he was interested to sell them. So after the person publicly announced the thing that he wants to sell, people interested to buying them would contact the person via private messages, and they can do the whole transaction in the private messages inside the forum, or they can exchange ICQ and email addresses and then do the transaction outside the forum. So from here you can see that the public messages are mostly for advertising, what you want to buy or what you want to sell, and private messages are where most of the global spam emails. So Brian Krebs, writer of this blog, he manually analyzed the chat conversation of Spamit and Rostock botmaster to find the real world identities of these botmasters. So we wanted to see if we can do a similar kind of analysis automatically using the linguistic tools we have. There are primarily two underground networks. The first one is the IRC channel, and the second one is web forum. In this talk, we are only going to focus on the web forums. We had the leaked data set of 5 forums. The first one was AntiChat, which was a Russian forum. We had 2 English language forums, Bad Hack and Black Hat, and we had 2 German language forums, Cutters and Lead Crew. So how did we get this data set? These data sets were leaked by anonymous people, and when we collected them, they were publicly available on RapidShare. Okay, so let's look at the statistics of these forums. This graph shows number of active members and lurkers of this forum. Active members are the people who actively participate in the forum, and lurkers are the people who just register in the forum but never post anything.